Good afternoon. Welcome to Conversations About Carbon. I'm going to be your host today. I'm Robert Brown. I'm a professor in the College of Engineering here at Iowa State University and also the co-director of the Bioeconomy Institute with lots of interest in questions about carbon. Today we have Anne Kimber talking with us. Anne is the Executive Director of the Electric Power Research Center at Iowa State University. Electric Power Research Center has a mission of performing research related to electric power and the associated technology transfer to the classroom and industry. Before she joined ISU in 2014, she served as the Director of Energy Services at the Iowa Association of Municipal Utilities. She has a PhD in ecology and evolutionary biology from Iowa State and is a registered professional engineer in mechanical engineering, which is my primary engineering area. Anne, welcome to our program today.
Thanks, Robert, for having me.
Let me get started. Maybe we can get folks oriented. Can you give us a primer on Iowa's electrical power system? What is the energy mix and how will this be changing over the next decade?
So Iowa is a really interesting state because we have a mixture of investor-owned utilities, city-owned utilities, and rural electric cooperatives. And over the decades, there's been consolidation and change in these utilities. But if you were to pull up a service territory map of Iowa, you would see that the cities tend to be served by investor-owned utilities or city-owned utilities, and the rural areas are owned by rural electric cooperatives and some investor-owned utilities. And it's kind of an interesting mix of these service territories. And the service territories are fixed by law that was passed back in the 1970s. So you've got cases where the rural electric cooperatives and the investor-owned utilities and the city-owned utilities might all serve customers in the kind of same vicinity, which is true for Ames. Actually, people who live in the city of Ames are served by 3 different utilities, depending on exactly where they live, which makes for some interesting collaborations among the utilities and some challenges as Iowa thinks about its own energy infrastructure and planning, because you have this huge mixture of utilities. So Iowa has changed significantly in its electricity resources over the last few decades. We used to be very, very heavy into coal. Probably 88% of our energy came from coal, even as short as 10 years ago. But that has rapidly changed. And the last statistics reported by the Energy Information Administration, which come from 2021, I think the 2022 numbers are going to come out next month. But in 2021, Iowa's energy, 58% of it came from wind, which is the highest of any state in the country. So that's kind of an impressive statistic, and that's likely to grow in 2022 and beyond. So we're going to be served more and more by renewables. Solar is still a really small percentage. I think 0.04% of our electricity came from solar in 2021. But 58% energy from wind is pretty high. And Mid-American has cited that 88% of the energy to serve their customers, their retail load, comes from wind. That's a lot of wind. So in 2022, about 12,000 megawatts of wind in Iowa, with another 2,000 megawatts of wind to be added by 2024 by Mid-American alone. So that's a lot of wind, a lot of renewables in Iowa. Our energy prices are low, lower than other states, sometimes 25 to 30% lower than the national average energy price for any sector, whether it's residential, commercial, or industrial. So I have low energy prices and a lot of wind, and we're a highly industrial state with very intense energy use. Not by residential customers, but by the manufacturing and ag-related industries in Iowa.
Thank you, Anne, for that primer on our system. seems like there's a lot of opportunities for Iowa in terms of renewable energy. Before I ask my next question, I want to make sure that the audience knows that they can enter questions that I will convey to you as we go along. But what I'd like to ask with respect to this opportunities in renewable energy, there was a recent report commissioned by Governor Reynolds. We called it the Carbon Report. We coined the phrase the Iowa Advantage with respect to carbon management. But we were primarily talking about the high productivity of our cropland and the capture of carbon dioxide through photosynthesis. Now, you point out we are a very heavy manufacturing state, as well as a very heavy agricultural state.
Mm-hmm.
But what is the Iowa advantage in terms of carbon reduction, carbon removal in the industry sector, in your view?
So I think the opportunity, well, there are several things. First of all, I think because we have very low energy prices, and we may even have negative energy prices depending where you are in the state. So it's pretty lumpy, which is not a technical term. But depending on where you are, if you're in the area of very high wind resources and you're operating within the MISO energy market, which is the grid operator that operates much of Iowa's electricity sales or generation, your prices may become very, very low, close to zero or even negative, even during the day, because of anomalies, even maybe, or constrained capacity on the transmission grid. So it's possible that industries that are seeking to decarbonize, who want a very high portfolio of renewable resources serving them, could locate in certain places in Iowa and be quite certain that most of their energy is coming from wind, or coming from wind and solar, or coming from wind and solar and battery, or even biodigesters or biodiesel. I think that that's very much possible, but it depends exactly on where you locate those industries. And I think that's where the challenge comes, is knowing exactly what you're going to be facing in terms of long-term energy outlook for your industry when you're deciding where to locate.
Well, let's talk about some of these industries. I think of heavy industries that they describe as hard to decarbonize, like cement, steel, and fertilizer production. Could you give us some ideas why those are difficult to decarbonize, and how electrification might offer some opportunities to do that?
Well, I think when you're thinking about large motors, for example, I think switching to, I may not be answering your question correctly, you may have to rephrase it for me, but if you can do electrification of transportation, if you can do electric motors rather than diesel generators, all those kinds of things, we know that electric motors are significantly more efficient just in their overall energy use than combustion engines are. There are statistics for EV transportation, for example, that for EVs, they're converting like 77% of the energy in electricity to driving the car, whereas conventional gasoline engines, for example, only use 12 to 30% of the energy that's contained in the gasoline. So if you can convert to more efficient motors, that really helps in electric motors. For cement manufacturing, where you've got a huge amount of heat involved, heat and water, I think those are really hard. I think those are very hard to convert. I suppose you could use electric heat, but you can imagine that the efficiency of that conversion from electricity to heat, you lose a lot of energy in that process. So I think that those are going to be harder to convert.
And that was what I was thinking of in terms of industries today that are very heavily dependent on thermal energy, like cement production and steel production. Can we decarbonize those? Can electric power in some fashion provide it? And as you point out, in principle, you could use electric power to do that for cement. How about the case for fertilizer, which it's not so much thermal energy itself, but the tremendous amount of chemical energy that is used in natural gas to convert it to fertilizer? Could you comment on an opportunity?
Are you thinking
Wind
of,
power.
I guess, are you thinking about renewable green hydrogen and green ammonia production?
Let's move into that topic then.
Okay, so I think, all of this depends on massive amounts of electricity that are used to split water molecules into hydrogen and oxygen. And then in a second step, you're sticking on a nitrogen atom onto the hydrogens that you've produced. I think you can do that in a number of ways. You can do it producing green hydrogen or green ammonia if, again, you have a big source of renewable energy coming from wind or solar, but more likely from wind, because that's the cheapest form of renewable energy that we have right now. If you have a big source of that, and you know that it's going to be close to zero in cost, then it works. I think if you don't have that, if you're buying energy at 5 or 6 cents a kilowatt hour wholesale, and maybe it's more than that retail, I think that's going to be very difficult. And if you need a continuous process and you have to firm that up with batteries, I think that's not going to be cost effective for quite a while. So I'm a little dubious about those.
Well, how cheap is renewable electricity going to get? I think I heard not too long ago the notion that it'd be too cheap to meter, or was that for nuclear power? Help me out.
I remember that. I think that was nuclear. I don't think it ever got that way. So there have been times when wind has been I've seen what are called purchase power agreements, where utilities are buying wind from a third-party developer. And I think I've seen it as low as 1.1 cent a kilowatt hour. That's incredibly cheap. That's amazing. And these are very, very large wind farms that the power is being delivered to that utility over transmission lines. That's, you can do a lot with a price like that. Solar, I've also seen really, really low prices. These resources are obviously much cheaper to buy than coal is now. So if you're lucky and you can get a purchase power agreement with a wind farm developer, and you can get prices like that, you can do a lot.
1 cent per kilowatt hour, just to put it in perspective, what am I paying here in Ames for my electricity for my home?
Well, if you're in the city of Ames territory, I think I'm also in the city of Ames, I think it's around 12 cents a kilowatt hour retail.
Okay, so 1 cent does indeed sound very.
1 cent is amazing. It's amazing.
Well, so maybe that will be our future, but you're saying we've got to wait and see how that develops.
Well, the problem, I mean,
Go ahead.
the problem is getting it to you. The problem is transmission. If we really, really want to have massive availability of renewable resources at these amazing prices, we have to have a pipeline to deliver that electricity to us. And that's where things could get difficult, because siting transmission, constructing transmission is really challenging. It can take years, like maybe 7 years, to get a transmission line sited and constructed and operating. So you could imagine that that's a huge hurdle in this overall energy transition that we desperately are trying to make work.
I need to understand that a little bit better. We've got lots of transmission lines running through Ames and through the state. Are you saying we need to substantially increase that, or increase it 10%? What's the issue here?
The issue is that even though we have enough transmission to serve us, if you were to look on the Mid-Continent Independent System Operator contour map, you would see that the prices of energy in the real-time market can fluctuate wildly if there are transmission bottlenecks, if there's congestion on the transmission system. Maybe there's a line that a squirrel or something happened to a line and it got taken out of service, even for a couple of hours. Then all the flows on the transmission system change and things don't work so well. And that can really drive up prices, because what we do now to manage congestion on transmission is we charge more for the energy that's delivered at certain nodes on the transmission system. So the transmission system is old in certain cases. That's not to say it's not operating well. It is. The transmission operators and owners are doing a good job of maintaining their system. But to deliver the kind of massive renewables we're talking about from the Midwest wind, even offshore wind, and then the solar resources that are more located in the desert Southwest, to deliver those to big load centers, we need new investments in transmission for that generation mix.
Thank you. And I'm going to pull us back to hydrogen. You mentioned green hydrogen. Just how many colors of hydrogen are there, and why should we care?
Okay, so I didn't pull up my what do you call it, the spectrum of different kinds of hydrogen, but I know that there's conventionally produced hydrogen, which is, I think, using natural gas, steam reforming, and I've forgotten the last part of that, hydrogen, which I think is blue hydrogen. I don't know if there's an aqua or a teal or a pink hydrogen, but the mostly I've been thinking about the conventionally produced hydrogen, and then this green hydrogen, which depends again on using solar produced electricity to split water molecules, which is kind of like photosynthesis. It's our closest connection with photosynthesis, to split those water molecules into hydrogen and oxygen. And then oxygen is kind of the byproduct of that. And then we get this tiny molecule of hydrogen. So, we could have another conversation about the efficiency of that production, but I don't want to get into that today. So.
Okay, but green hydrogen truly has no carbon emissions associated with it.
If it's truly green hydrogen and it's produced from renewable sources, it should have no carbon emissions associated with it. But if you're buying energy from the MISO grid to make that hydrogen, it's probably not going to be completely green, because the MISO generation mix, because all the electrons go everywhere, you wouldn't be able to necessarily certify that your hydrogen was completely green. It might be kind of teal, blue-green. So.
Well, related to that, I believe, is one of the questions that's popped up. What are your thoughts on energy storage? What technologies are likely most feasible for Iowa, at least in the near term?
So there is a lot of interest among the utilities in energy storage. And the most conventional one is the lithium-ion battery storage. That's the one that's most readily available, and quite a few utilities are doing pilot projects with battery storage. It's very expensive still. There are other kinds of other kinds of energy storage. I'll highlight one is pumped hydro. We don't think about pumped hydro very often when we think about Iowa. The biggest pumped hydro facility is in Ludington, Michigan. And that's basically pumping water uphill using off-peak, like nighttime wind energy, and then releasing it to run downhill and power a turbine during peak hours. There's increasing interest in pumped hydro. Another kind that I think has promise, and I think we'll see more of this, is what's called flow batteries. And the most, I guess, well-known type, at least to me, is called vanadium flow batteries. And these are of interest because unlike a lithium ion battery that runs down and then you have to, it's got kind of a fixed capacity and then you have to charge it up again. Flow batteries, you can keep adding basically fuel to the battery, and you can keep it running for much longer. So it's used for what's called long duration energy storage. And I think a lot of the technological problems have been solved with vanadium flow batteries, and I think those could be another really good storage option. For Iowans, I'm thinking of, we don't think very much about thermal storage or ice storage, but if we're thinking about buildings, in California, for example, they've done just ice storage in the basement. You've got this huge block of ice. I'm oversimplifying this, but you can use that with a heat exchanger and you can cool your building, or at least you can help cool your building, and then you can refreeze the ice when the energy costs are cheaper. I think we should be thinking more about thermal energy storage than we typically do. But that's a much more granular approach that might work for large commercial buildings in our cities, but not every homeowner is going to want a big block of ice in their basement. But then the other storage that we have available to us that maybe we need to be investing more in is just geothermal heat pumps, where you're taking the heat or the temperature gradient in the earth, and you're using that to pre-cool or preheat the air that you're using to cool or heat your house.
Now, this issue of energy storage, I've heard more out in California than in Iowa. So we've built out a lot of wind power without having to build these giant energy storage systems yet. Why haven't we, or at what point do we need to start thinking about doing that in Iowa?
You ask such great questions. So there's a couple of things. We have this giant grid operator called MISO in most of our state. And where MISO ends to the west, there's another big grid operator called Southwest Power Pool. And our storage has kind of been the transmission grid itself, because we have we're operating the grid as kind of one giant creature. So where our wind goes up and down, we're balancing that with all these other resources. And unfortunately, perhaps some of what's backing up that wind or firming it up or acting as storage is coal piles at still operating coal plants. That's one. But the other really interesting part of MISO is that another part of the energy storage that balances our grid are all the hydro resources in Quebec and Canada. So that's part of how this grid works, is because we have our border doesn't end with Iowa or even with the northern border in the United States. We're using Canada's resources as well.
And will that be able to continue, or do we need to be truly building out capacity in terms of energy storage?
I think we need to be building out capacity for energy storage.
Mm-hmm.
And part of the reason there's this huge conversation that needs to happen between, to what extent do we invest in bulk system resources, like the giant transmission lines, the giant wind farms and solar farms, and all the resources to support those. And how do we balance that with building microgrids, community resources, smart distribution systems? There's a huge discussion about economies of scale versus local community resilience in the face of a derecho. If you have a massive storm and it knocks out your transmission lines, because many of them cannot be put underground, it's just cost prohibitive, incredibly difficult to do this. So your transmission system is out, and all of a sudden, City of Ames is operating with its own resources. How do you balance those investments? Where should the energy storage go, and who does it benefit? Who pays and who benefits? I think that it's complicated,
Well, here's another complicated question that came in. I'm going to have to paraphrase because it disappeared before I could ask it to you. it has to do with the siting of wind turbines and what are the issues? I mean, mostly we've seen these located out in rural areas, but in principle, they can move closer to urban areas, which would be an advantage in some respects. But what are the issues that are arising as we look at doing that?
So, you know, when you site wind turbines, you have to comply with National Environmental Policy Act considerations. There are many studies that have to be done on migratory birds, bat habitats, wetland habitats. All those things have to be satisfied. You have to do sound and flicker studies and all those kinds of things to see how these wind turbines might impact residents who are living nearby. So all of that has to take place. You have to site the wind turbines in an area where the wind is good. So you've got to figure out all those wind resource studies. And then there's two other big things. You have to comply with local ordinances that may prohibit any wind development in a county, or may require certain setbacks away from the road and away from the nearest house that really make it impossible to put a wind turbine in a particular area. Kossuth County has ordinances, that's just one example, but there are several other counties in Iowa that have ordinances that severely restrict wind development. The other problem with building new wind farms is not just finding places to put them, but there's something called the Large Generator Interconnection Queue in MISO, or also in SPP. And that can take a very long time to get through, because they have to study whether your wind farm is going to adversely impact the grid. And if it does, you may have to build new transmission. And if you have to build new transmission, that may make your economics not work. So it's a lot of problems.
I want to turn to a question sent in. Consider a future, a hypothetical future, where many homes and commercial buildings generate their own energy. How can we make that happen? And how does that affect the need for new transmission lines?
That's a really great question. I think about this question all the time, because it's this question of balancing the needs of a community and the needs of what you might call the greater good, however you define the greater good. I think to build local resources can really help with community resilience. You're just lowering the risk that everybody is going to be out at the same time. You know, if the transmission line gets severed to your town, and you have your own local resources, even if it costs more, even if you don't get the 1 cent wind power, but your lights are still on, it's probably worth the investment. Of course, you want to consider that really carefully, like how you do that the most cost-effective way. I think I could talk about this question for a long time, but there's a couple of things that are going on now. Department of Energy is issuing a lot of funding opportunity announcements. We call them FOAs, for small communities to develop projects that build renewable energy and energy storage and energy efficiency and smart grid stuff for their small community. And these are especially coming out now for communities of fewer than 10,000 people. So Department of Energy is really interested in trying to do these kinds of local investments and to help pay down the cost of that. There's so many things to consider if you're trying to do like a community-wide local energy infrastructure project. One of them is ordinances, the soft costs of permitting for solar and wind, maybe, or district geothermal heat pumps. What if a neighborhood all went together and decided that they were going to have their own little engineering study done of geothermal for their whole neighborhood? You'd really cut down on your external electricity requirements for heating and cooling. How many communities do this? I don't know. I mean, my neighbors and I are talking about trying to do this. You know, what if you did a community solar project? That could be a great project. What if you did a community distributed wind project? Again, Department of Energy's all over that. They want to see more distributed wind for rural load centers. Could you do that? Would the wind efficiency be as good as these 3 megawatt wind towers? No, it's not going to be as good. Your wind resources is going to be messy, but maybe you don't need it to be that good because it's local. And maybe you ought to take a really thorough investigation into how much energy efficiency could you do first before you do any of these other kinds of things. And that's like the, what do you call it? The orphan child of energy policy. Is, you know, how many people think about the idea of just not using quite so much energy? And Robert, can I just go on just a little bit longer about this? Because I think about this stuff all the time.
Please. Well, I've got questions coming in.
Okay. So I didn't look up this morning the useful energy that comes out of an LED light bulb. But let's say that for an old incandescent light bulb, for all the energy that it took to get those electrons to your light bulb, like only 3 out of those 100 electrons, let's say, that got to your light, ultimately got to your light bulb, only 3 of them turned into useful light. Which means that turning off an old incandescent light bulb saved you not just 3 electrons, I'm sort of overgeneralizing, but it saved 100 because so much of that energy that went into producing light actually went off as heat. So even LEDs are not that great. It might be as much as 20 of those 100 units become light, but honestly, the act of conservation is kind of a radical act, and we don't talk about it. So, okay, end of soapbox.
Very good. From some of the questions, I get the notion that the idea of siting new transmission lines will be a little controversial. So one question is, how much could we avoid expanding the transmission system by simply adding more lines to existing towers? Is that even a possibility?
I think that utilities are trying as much as they can to put new towers and new lines in existing right-of-ways where they can, or just repower those old lines where they can. I think that's they're highly aware of how difficult it's going to be to site major new corridors. So I think that's, you know, that if that's not the first step they think of, it's like very early in the steps. The problem with siting multiple lines in the same transmission right-of-way corridor is that if there is a tornado or an ice storm or something, now you've knocked out like 2 sets of transmission lines and all the distribution underbills that might be underneath them, and you're in a real pickle.
Wow.
Some people ask about undergrounding transmission, and you can, it just becomes incredibly expensive. The other thing, and I'm not an expert on high voltage DC, but honestly, if we could do high voltage DC, it's going to be ultimately cheaper because it has so much capacity to deliver a lot of power across the region, and the right-of-ways are much smaller than alternating current transmission lines. But we're not used to seeing DC in Iowa, in the Midwest. You can see it around, some of it around Chicago, but not so much here.
Very good. Got a question on Iowa's social preferences regarding renewable energy technologies. There are multiple options. Do you have any perspective on urban versus rural choices in these? Let's just open it up in energy choices. Have you seen anything like that? I haven't seen, there is a professor at Iowa State, her name is Hong Li Feng,
and she's in the economics department, and she's really interested in, and she's done some work on how communities make decisions about renewable energy, whether it's siting, whether it's local projects. And I would, maybe that's another conversation about carbon that you need to have. My sense is that in talking to the few people that I talk to, is it really depends on who the winners and the losers are. If it's one person getting a lease for one turbine and everybody else gets to look at that turbine for the next 40 years, that might not be so widely accepted. If it's a community that has the city council and the members have decided that they want to go down a certain path, it's a completely different animal. I think that where the incumbent utility serving that community and the community have a tight connection, a tight positive connection, much more can get done. To the extent that the community sees their utility as their partner on these projects and they share the same goals, then a lot more interesting things can get done.
Okay, I've got a question about, we're going to hand the money to you. And what is your investment going to be to improve the resiliency and sustainability of the grid? Both of those, not just one. What is it, that investment, going to be? You say, ask how much money you have available, you name your price, but what is that one thing?
Just one thing. Oh. So I actually have a grant like this right now. It's called it's called a FEMA, Federal Energy Management Agency, BRIC, Building Resilient Infrastructure for Communities Scoping Grant. And it is to go to communities in Story County, so all 13 of them, and say, what's important to you to keep the lights on for? That's a terrible sentence. So the critical loads, we absolutely have to keep the lights on for XYZ. What are our resources? Let's match our potential resources with our critical loads and figure out how much it would cost to at least serve them using renewable energy, energy storage, upgraded distribution, smart switching, and all the kinds of cool technologies that we have now that we didn't have 20 years ago. That's what I want to do for my next 2 years, is exactly that. And what's interesting and really challenging about that is that in order to do something like this, we need data, we need information about how much does a school take? How much does it cost to run the school? How much does it cost to run, how much energy does it take to run Mary Greeley, for example? Or, and when do you need the energy most? How much energy does it take to run the local Casey's? And how much energy would it take if you didn't have to power the pizza maker and the beer coolers? So that could be a problem. But, it's all about, our solutions depend on us knowing what we really need to do. And like the critical needs assessment, it's really hard to come by that data.
I'm going to go back to hydrogen. You mentioned pink hydrogen. I looked it up. There is a pink hydrogen. And that is hydrogen produced by electrolysis using nuclear power.
Nuclear.
Why don't you comment on nuclear power as part of resiliency and sustainability?
Yes, I should have done that. So there is a lot of interest in small modular nuclear power. And, the technologies are under development. Department of Energy and Bill Gates have pilot projects under development. And we know that utilities in Iowa are very interested in the possibility of small modular nukes. And the reason that they're so interested is because is because at the end of the day, it becomes very, very difficult to run a grid all the time, 8,760 hours a year, on wind, solar, and batteries, because of the problem of what's called energy droughts. And energy droughts happen when, let's say, you've got 5 days in March and the wind isn't blowing and the sun isn't shining and your batteries have gone to zero. What are you going to do? And that's a real problem. And we've tried to look at this problem by saying, well, we're going to draw from a larger area and a larger area to balance this all out. We can't quite do it. Can't quite do it. So either we're going to be continuing to run natural gas, baseload generation, or we're going to have something else. And if it's going to have to be zero carbon, it's probably going to need to be small modular nukes. And I think it's going to be expensive, and I think society is going to have a lot of questions about this. But I don't think we can get to 100% carbon-free grid without them.
Well, some environmentalists might call that hot pink hydrogen. And the question is whether people would prefer the small modular nuclear reactors or the renewable energy. And let's face it, I've realized this for the decade or more that I've been working in renewables, is we do impact the landscape, whether it's producing biofuels or solar or wind. So I think that is an issue that the public's going to have to grapple with, and there are no easy technical solutions to it.
That's right. There are no easy technical solutions to this.
Which brings me to my wrap-up question. In your role of looking at the future of electrification and decarbonization, what keeps you awake at night?
So I was reading, this is kind of apropos, I was reading a quote by Rachel Carson this morning, and somebody had just sent it to me. And it was about teaching children to love nature, to have a sense of wonder about nature. So you don't have to really drill them in all the facts about it. They just have to know that it speaks to them. There's something beautiful about it. There's a sense of magic. And I've actually been thinking about that, about the grid, to have a, which is kind of crazy maybe, but if we're gonna, the thing that scares me or keeps me up at night is that we didn't impart a sense of the treasure that having this thing called electricity that powers our houses and makes our lives comfortable and provides us information. We don't value it. We don't value the complexity of it and the really deep challenges we have to overcome from it. And what keeps me up at night is that there's a brownout, there's a blackout, something fails. We tried to do wind and solar, we tried our best, and something failed. And society, whether it's local or national, they turn away from it because a mistake happened, and it will happen. And I fear that because it's hard to recover from bad things that happen. And we have such very high expectations of our grid. We expect our light should be easy to flick on and off. It should always be there for us. But the truth is we can get to 98% renewable grid. We can do that. But the last 2% is going to be hard and it's going to be expensive.
And I'm just going to add 2 more comments real quickly. Sam Wormley says geomagnetic storms keep me awake at night. We know that's not due to climate change, right? So that's a good one. And then Lisa Schulte Moore says she looked up the concept of energy drought, and it has not been published on it. And she's encouraging you to write a paper on it. I'm going to suggest maybe there's a book there as well. So I think that's all the time we have. I appreciate Anne joining us today for conversations about carbon. we will resume this conversation in the fall. You'll be getting notices of it. Again, thank you very much, Anne.
Thank you, Robert. Thanks for having me.